say for example, you have certain metals, right? Now when you keep on using, wear happens, am I right or not? Any metal, when you keep on using, wear happens. Say for example, you have a knife, right? When you keep on using, what happens? Say this is a knife, right? When you keep on using this or cut something again and again and again, this thickness is going to reduce, am I right or not? At the end of the day, I need to throw this and replace it with the other one. That is what we normally do. But this particular technique, friction surfacing, what I do is, once this thickness is reduced in such a way, this is a knife, assume that this is a knife. Now I have reduced this thickness to a larger, the thickness is lost because of wear. Because of repeated usage, this metal is lost. Now what I am going to do is, I am going to go for this particular process, apply some metal so that I increase the thickness of this one and reuse it again. Are you able to understand what I am saying? That particular technique you call it as surfacing. I generate a surface, and that is why I call this one as friction surfacing. You understand what I am saying? That is why I call this one as friction surfacing. So, by traversing a workpiece underneath a rotating consumable, deposits can be laid onto the workpiece. See, machining you do normally. What we do, the purpose of machining is to remove the metal. Are you able to understand? Remove the metal. You want to shape a particular component, you just melt, pour it in a cavity, and solidification you can get a component. Or otherwise, you have a component, remove the unwanted portion, you get a component. Or otherwise, you heat it to a red hot condition, blow it, make it to the required shape, you will get the component. But this particular process, what is this is, you have a material, you apply metal over it to get the required shape. Are you able to understand what I mean? This particular technique, what do you call this particular technique? You call this one as friction surfacing. This is a wonderful technique which you can generate in a milling machine. But of course, you need to think how to go for a milling machine, vertical milling machine. Right? When you rotate it, you how to force it, how to metal, but your milling machine should have that capacity. You should have some technicians around this to work in this particular thing. Right? Now, so particularly brake disc drums. In brake disc, if you see in automobile vehicles, now what happens that brake disc keeps on wearing because you keep on using brake, that rubs and goes off. Right now, if you want, normally what we used to do, we used to replace it with the other one. Or otherwise, you can go for this technique. You can generate. You go for surfacing and generate. You can remove the worn-out portion. Now that is what wonderful here. The most wonderful here is you can remove the worn-out portion. Now I will show you a particular video here. Now how friction surfacing works.
By using the friction surfacing process on this earth mover component, it's possible to apply an extremely thin hard wearing layer to a relatively soft and inexpensive substrate material.
Ploughing device, right? Now if you keep on ploughing, now what happens? The thickness is going to reduce. Now in this case, now what we have done, we have gone for a friction surfacing process, reuse it again. Instead of changing the ploughing device again and again, you can reuse again. Now that is the advantage of this particular friction surfacing. Right? Now then this is another important process, right? Now I think you would have gone with the extrusion process, isn't it? Extrusion process is very simple, just what do you call you can take an example as a toothpaste, right? If you have look at the toothpaste, inside you have a paste. When you squeeze it from one end, depending upon the cross section of the toothpaste mouth, right? It can be round or square or whatever it is. You get the paste get extruded. Now actually the paste get extruded. Now what happens? Now you have a cylinder. Now you put the metal in a what you call hot extrusion means you put the metal in above the recrystallization temperature. Then you pressurize it from one end, the other end opening. What you get? You get the metal extruded. Now that is what you would have seen. Am I right or not? Now that is a tedious process. Why? Because you need to heat the metal, take it to recrystallization temperature in case of hot working, or if it is cold working below the recrystallization temperature. So in both the cases you need to work with the metal before going for the extrusion process. You understand? But here the most important thing is in this friction extrusion. Now what you do? You have a rod. Now you have a rod. Now this is a tapered portion. Now what you do is you just you try to rotate, apply pressure and rotate. Now in this region you are going to produce a plastic state metal, same as how I told you for the friction welding. You got it what I said? Now once you produce metal in plastic state here, because of this force what you are applying, you can extrude. Are you able to understand what I am saying? So this process is much easier than the ordinary conventional process what we have right now. The other one, when you go for a wire drawing, normally what we do, we put the metal in a plastic state. When we move this ram up, now what happens? You have an opening here. Now the wire is generated. Am I right or not? Am I right or not? Now here is a technique, the friction technique. Now what you do, in the conventional method, this is stationary. Inside you have a metal in the plastic state. You understand? You have a metal in the plastic state. When you move this ram up, this metal will be squeezed in. Because it is in plastic state, it will come here as in the form of a wire or rod. You got it what I said? Now here what I am going to do, you have a metal in the powder from the scraps. What is generated in your machine shop? What you do is you just fix it inside, rotate it, okay, and apply pressure as well. So now what happens? Metal will be here, because this is compressing at the compressed state. What happens? The metal undergoes a severe friction, which makes this scrap to be in the plastic state. Now that can be easily drawn to you. Like this, you can do it in a workshop. This you can do it if you students in third year think about mini project. Just prepare a die. You can prepare this die, and this one put scraps inside. Try to rotate and blow it. Certainly you can go for that, right? But again I am telling you, because you are going to work with metals high temperature, that can create harm for you. So that care has to be taken, utmost care. Now I will show you one particular process, and probably you can understand how easy it is. Now all the metal scrap which is available is just put in a die, and this is molded in a chuck, rotating chuck. Very simple. And now what I am going to do, the RMS meter. Now with this one, I compress it. When I compress it, I have an opening in that plunger. Now it is going in. Now what is that going to happen? On the other side, it is going to give you a wire. This I think even a third year student who are working on design and fabrication project. Now what is design here? The die design, the two die design. Probably you can concentrate on that. When you say design and fabrication, design should be there, fabrication should be there. Other than this, if you have that cannot be evaluated. You should have design. The die design is there. So by changing the RPM and the plunger pressure, now again that we cannot measure. But of course, with the hand, human force, now how much you can produce, because there is you can create some attachment so that you can push the plunger inside, right? And you can do final projects. Probably you can work when you change the RPM with same constant pressure. Now how the rod is made. Now what is the mechanical properties of the rod. Now probably you can think about that, right? Linear friction welding. Now I have shown you something about rotary friction welding. I have shown something about rotary friction welding. Now when I say linear friction welding, I have two workpieces. Just to rub against each other, create the friction, produce plastic state, then holds it. Now that becomes a linear friction welding. So earlier I have told about rotary friction. Good. Now when you look into this one, now I show you this one.
Low cost linear friction is an alternative line.